Hi guys, we are on Unit 3, Part 2, Day 17 notes. We're kind of almost to the end. We have 2 more days of notes for this section, and then we'll have our project, and the project will cover all of Unit 3, so it'll just be a little bit of everything. But okay, the title for the notes today is Discriminant and solving by the quadratic formula. So we did the quadratic formula yesterday. It's not really going away today. The discriminant is part of the quadratic formula. So it's kind of in there, and I'll show you what I mean in a second. So I did just write the discriminant on the top. D stands for the discriminant equals b squared minus 4ac. And we'll get there, but let's fill out this chart on what the discriminant means. So when you're finding the discriminant, you'll have basically 3 scenarios that you could possibly have. The first scenario is if d is greater than 0. So basically, if d is positive, like positive 12 or positive 100, something like that. If that's the case, then you're going to have 2 real roots or 2 real solutions to the problem. And your picture could look something like this parabola, where you have 2 solutions, or here's a different picture where you have 2 solutions. I've made little dots, some little circles there. So that's the first thing. The second possibility, if d is equal to 0, and that's self-explanatory. It's 0 or it's not 0. If it is equal to 0, that means you have 1 real root. You have 1 real root. And here's an example. I'll give you 2 little pictures. It could look something like, this, where it just touches down 1 time, or something like, oh, that one's kind of bad. Something like this, where it just touches it 1 time. That would be 1 real root, where you can see where they cross. The last example, the last one, is d is less than 0. So that's if d is negative. If d is negative. If d is negative, that means you're going to have 2 imaginary roots. Roots. 2 imaginary roots. Basically, that means you have no real roots. You have 2 imaginary roots. And your picture is going to look, something like this floating graph. It doesn't cross. Or this floating graph. It doesn't cross. Those would be no real roots. They're imaginary solutions, so you cannot see them. And it would look, something like that. Okay. Here we go. Use the quadratic formula. So again, I know I said it's not going away. Use the quadratic formula to solve this, and then state the discriminant. So I'll show you where you can pick up the discriminant very easily. So yesterday we talked about the a, b, and c values. So the a is the number. Technically there's a 1 in front of the x squared. So a is 1. B is the number in front of x, so that's -5. And c is the number that's kind of by itself on the end, so that's -14. So I have my a, b, and c. Just like yesterday, I'm going to take those and I'm going to plug those in. So x equals negative b, so -5, plus or minus square root b squared minus 4 times a times c all over 2 times a. So again, you can just pause and make sure you put everything in the right spot, but that's all my numbers in the right position. And again, I'm going to focus on this yellow part underneath, and you could take your phone, your calculator, whatever, and you could type that in there, do it piece by piece. But what I have here is in the front, I have -5. 2 negatives make a positive, so I have +5 plus or minus. And again, I type that into my calculator. I do that calculation, I get 81, and then that's over 2. Okay, here's the part. We didn't say this yesterday, but we're going to focus on breaking this down, and here's the part that is important. That number that we just have, that highlighted 81, that is your discriminant. So the discriminant is equal to 81. Let's write this. Discriminant is equal to 81. Is the discriminant, which is 81, greater than 0, equal to 0, or less than 0? Well, 81 is greater. It's a positive number. It's bigger. So look at your chart above. If it is greater than 0, that means your answer is going to be 2 real roots. And that's what I'm wanting to know for the discriminant. So when I continue on in a moment and I find my answers, I'm going to have two real solutions, two real answers. So I'm going to continue on, and I'm going to go ahead and simplify the square root of 81. This one should actually be pretty nice because the square root of 81 is a perfect square. Hopefully you know the square root of 81 is 9. So I can write 9 there. So I have 5 plus or minus just 9 over 2. And let's take this piece by piece because see how these are just numbers? Let's break them down. What is 5 plus 9 divided by 2? 5 plus 9 is 14, divided by 2 is 7. There's one of your answers. What is 5 minus 9 divided by 2? 5 minus 9 is negative 4. Negative 4 divided by 2 is negative 2. And there's my other answer. And that checks out because we said that there would be two real roots. Well, there's my two real roots right there. We actually found them. Okay, let's do another one. I'm going to scoot over so I can have a little bit more space. Same instructions, solve by quadratic formula. Let's stop and talk about the discriminant. So let's take it piece by piece. A is the number in front of x squared, which technically is a 1. B is the number in front of x, which is a 10. And C is the number, in this case, it's by itself, that is a positive 22. So I have A, B, and C, and I'm going to plug them in. X equals negative B plus or minus the square root, B squared minus 4 times A times C all over 2 times A. So again, you can kind of pause and make sure you put everything in the right spot, but there is all my pieces in the right position. And I'm going to go ahead, just like the last few times, I'm going to focus on this part underneath the root, the yellow part. Again, use your phone, your calculator, whatever, and type that in and let's see what you get. When you type that in, you should be getting negative 32, and then that's divided by 2. And again, I want you to stay focused on that negative 32. This is your discriminant. So the discriminant is equal to negative 32. Then you need to think about your three possibilities. Is negative 32 bigger than 0, equal to 0, or less than 0? Well, negative 32 is a negative number. It is less than 0. So if you look at your chart, that means we're going to have two imaginary roots, or two imaginary solutions. So that's important. That comes from that negative 32. And that tells you when you solve this in just a moment, you're going to have I, imaginary, in your answer. So let's break this down. So I'm going to go ahead and do my factor tree. And where did that go? I'm going to break it down in orange here. What multiplies to 32? Well, I think of 16 times 2. What multiplies to 4? What multiplies to 16? 4 times 4. Multiplies to 4, 2 and 2. I'm going to circle my pairs, underline my leftovers, and let's clean this up. So I have x equals negative 10 plus or minus. I have a negative underneath the root, so that means I'm going to have an I with my answer. The pairs that I circled come to the outside, so a 2 and a 2 come to the outside. 2 times 2 is 4. But I have a leftover 2 that has to stay underneath the root. So this is what I have so far. I'm going to see if I can simplify this just like we did yesterday. I'm going to highlight these green. Remember, it's an all or nothing. Those 3 green pieces have to be able to break down or don't do it. In this case, 2 goes into all of those green pieces, so let's break them down. So I have x equals, that's going to become negative 5 plus or minus. This is going to become 2, then the I, then the root 2. And then it's going to be all over 1. And then technically, do you need, let's move back up. Do you need the 1 underneath there in the denominator? Technically, no. You could just write negative 5 plus or minus 2i root 2. You don't need that 1. If you have it, that's fine. But see how we said for the discriminant, you're going to have two imaginary solutions? Well, yeah, we did. We have I in our answer. We have a positive version and a negative version.